about the future in the AI of radiology from the Professor Dr. Curtis Langlotz from the Stanford University USA. We will have a question and answer in the panelitic discussion later. And right now, I'd like to introduce the next speaker, Professor Dr. Trần Minh Quân from Vietnam. Will present the application of the AI in the healthcare. Thank you.
Good morning. It's a great honor to be here to talk about the latest technology that bring you to the next level of radiology. So far in the previous section, we have discussed what to be done. So in this section, I'll be happy to share how to get those things done with the latest technology with NVIDIA. My name is Quang, I'm a senior developer technology in NVIDIA Vietnam, and today I'm going to present the toolkit, the open framework that NVIDIA provides for developer over the world to develop the next generation of radiologist technology. So let's get started. So I'm going to talk about one of the core toolkit in NVIDIA Clara SDK. And the core objective that solving the 6 workflow in radiology. And I'll talk about the feature as well as the functionality and how can we get started with those SDK. And I'll conclude my talk after that with the question answering at the end. So MONAI is standing for Medical Open Network for AI, which means the Medical Open Network for Artificial Intelligence. So networks in here is just the neural network. So we talked about how to leverage the bio-inspired perceptron in machine learning to do the complex job by dividing the job into several simple jobs so that we can solve gradually with the gradient descent. So as you can see that MONAI have provided you the key solution for 6 workflow, including the generating synthetic data, AI-assisted annotation, training the 3D segmentation model, so on and so forth. So the first one is about how to leverage Gen AI to generate more and more data. So we try to build the big data set, and we try to leverage the key connection between the medical text and medical imaging, and that's why we come with the Gen AI in medical imaging. So the basic block of the Gen AI are 2 components. So the so-called UNet, published by Dr. Ratnam in Mikai 2015, and the Transformer, so published by Google team in 2017. So those 2 basic building blocks will help us to connect the knowledge between the text-based and the image-based together so that we can form the Gen AI methodology and generate the data. So with the image that's generated from our workflow, so you can freely distribute the material for educational purpose, so which means the next generation of the doctor or medical doctor can freely access the knowledge from the image space, so without considering who is the author of the image. So that's elevate the learning curve to the next level. And so the next workflow is the AI-assisted annotation. So as you already know that when we work with the medical doctor, so doctor usually pay attention to the organs or the disease that lay on the image. So we provide the workflow to assist the doctor to annotate whether this is in the DICOM format or it is in the like Nifty format. So it helps the doctor to quantify the segmentation, and after that can give the final decision. So it has been packaged into the plugin and the API microservice and integrated with many like common viewers, including like 3D slicer, including QPath for pathology imaging and the endoscopy image. So for the like Open Health Imaging Foundation or HIP viewer, so we also have the plugin to that the viewer can render the image directly on the website, as well as we are working with like many like big company like Kitware and other like community toolkit like CVAS, so computer vision annotation tool, so that it can freely distribute it and you can integrate on the tool that you desire to work with. So the third workflow is the way that we quantify the process of training the 2D or 3D segmentation. So the developer can jump into like the curated data set to have to shorten the time of training their models. So as you can see that it's improved the productivity of the image understanding after fully going through the segmentation. So with the first three workflow, NVIDIA has won several challenges in the top conference in medical imaging, including ISB and MICAI. So you can see that we won the kidney segmentation, first place, the aortic tree segmentation, MRI segmentation, and 3D ultrasound segmentation. So this has been proven that if we leverage the already built pipeline or toolkit, so you will like develop on your own purpose and study plan. So the fourth workflow we focus on is the federated training. So nowadays the healthcare data is like very sensitive, and we don't want the data going outside the hospital size. So that's why we developed the federated learning. We install the machine or appliance on-site in the hospital, so that when we distribute the neural network across multiple sites, the data just come into that appliance, and we train the neural network on that appliance. So which means the data will not be going outside the hospital side. We just take the gradient or the neural network weight back to the orchestration, and so that it will diversify and generalize the model after the training. For example, if we want to generalize the problem of training across multiple cities, so we can set up this workflow and we can collect the achievement later. So training AI models is complex. So we simplify the step by step, and it can be broken down into like several modules that you can see here. So it have the Monai course, Monai label, Monai deploy app SDK, and Monai application package. So each module I will present like in detail later. So as you can already see that the map, Monai application package help you to deploy or patch everything so that it will be ready to be installed in your local hospital or in your like university hospital. So the next one I'm gonna present is the functionality and the feature of Monai. So we divide it in 3 phases. So for the model development, so we collect the data, curate the data. So Monai label help you to clean the data as well as the annotation of the data. And then after training, so we can pack everything. It can be installed anywhere. It can be installed on the cloud services or installed on the on-prem machine in your local hospital, or even can be installed on the edge device. So several medical devices require special treatment of the installation. So we provide the protocol to do that as well. So this is the overview of the Monai stack. You can see that we provide several tutorials, including the classification, segmentation, registration across multimodality. And in the Monai core, so we implement the basic, very intensive basic image format I/O for use. For example, DICOM stack or the Nifty, so that when we translate the pixel coordinate to the image coordinate, it will maintain the physical behavior of the image as well as the orientation of the image. So we test this Monai workflow across multimodality, including the MRI, CT, pathology, X-ray, endoscopy, and for across multitask of the application, including segmentation, detection, classification, registration, as well as reconstruction. So reconstruction means several data that from the scanner is not available in the image format yet. For example, in CT we have a sinogram, so we have to perform filter back projection to reconstruct that. So in some cases, several metal artifact or useful problem occur because we don't collect enough view. So we have to leverage the power of AI to reconstruct those images. Same thing with MRI reconstruction. So the data is represented on the case-based format. So we have to perform inverse Fourier transform to reconstruct the MRI. So sometimes the case-based collected are not enough information. So we have to perform the regularization to do inverse reconstruction of the MRI data. And I already said, so Monai label can be installed on-prem, so which means you can install on a separate machine, and your application, workstation application, can call that API or call that inference microservice. So in radiology, you can leverage the power of 3D slicer. In pathology, we can use QPath, and in endoscopy, so we can use CVAT to annotate your data to have further analysis. And this is the workflow of Monai core. So it's robust, and backward we design the core of the Monai compatible with TensorFlow and then PyTorch, two famous libraries that used to train the neural networks in this day. And once the model has been trained, so we can use the trained model. We design the reference flow, reference architect, so that you can deploy the trained model on device or on-prem services in your hospital. So let's get started with Monai. So as I already said, so it can be installed anywhere, can run anywhere, especially on the DGX machine. Or even on the DGX cloud. So we provide the cloud first experience, so that for the first hand we don't need to invest a lot of money for infrastructure. So we can experience the high performance computing with AI services in DGX cloud. And if you go through the how to install, it's a Python based, so it can be easily installed. And we have several tutorials as well as the workshop has been organized in previous year of MICAI, so we can follow that and then find the appropriate solution workflow that match your problem. So we are open sourcing everything so that all of the developer in the world can start without hesitation. So I will skip the enterprise support, which means if you like purchase the DZX, so you will have like 24/7 support from the high experience engineer from our team. But with that, I will conclude my talk in here. So I would love to have any question, or I will take that offline. Thank you.
Thank you, Mr. Trần Minh Quân, for your very interesting presentation.